Welcome to tSQLt Live DevOps Edition. If you're looking to learn more about DevOps, Data Platform DevOps, or DevSecOps, you have come to the right place. In this video series, I'm talking about what DevOps is, why it is important, how to get started, and also some more advanced topics. So no matter where you're at in your DevOps journey, there's something for you here. Today's topic is how to choose a unit testing framework. And for that, I would like to use what's called a Moscow board. I would like to look at with you what features must be present for a unit testing framework, what should be present, but you could live without, some nice to haves, and also some features that you might find in some unit testing frameworks, but that you really should not include in your decision for selecting a unit testing framework. So let's look at the first ones, at the must-haves. In my experience, for a unit testing framework to be effective, to help you achieve the goal of finding defects early, reducing your maintenance overhead, and making everything easier in the end, helping you deliver value faster to your customers, to the end users. The features that you need are isolation. And isolation means you need to be able to run a test, just one test repeatedly, always get the same results, no matter if other tests ran in front of it or not, no matter what the environment, the state environment was like at the beginning of the test. So your framework must give you the tools to set up the environment so that your test can work the same way every time you execute it. It needs to be repeatable, and a big part of making that isolation happen is it needs to provide test doubles. So test doubles are there to allow you to write a test that focuses on one module and is not impacted by the code in another module. Say if you think about database code, if one stored procedure calls another stored procedure, if that other stored procedure contains a defect, you don't want the tests that test this stored procedure to be impacted by that. So you want to be able to create a test double for that other stored procedure. That test double that behaves in a way that is helpful to this test. Now, whether you want to write a bunch of tests that test both stored procedures in conjunction, or if you want to write tests that test stored procedure A and separately a bunch of tests that test stored procedure B, that is a topic for another video. But if we assume that you're in the place where you test the two stored procedures separate from each other, then you want to be able to write tests for stored procedure A that are not going to fail if there is a bug in stored procedure B. And that's what test doubles are there for. You need the ability to test small enough units. That kind of goes back to isolation. You don't want to exercise the entire code base every time you test, you write a test for a small module. You actually want to have the tools you need to test just that module. And that's independent of the language you're using. So if you're thinking about a class, maybe the framework allows you to test private methods in that class, that is another philosophical discussion. Should you test private methods or should you only test public methods? A topic of another video. But if you want to test, sometimes you need to test private methods, and then having a framework that gives you the tools to make that happen is really helpful. Automatability, yes, that's really what unit testing is about. Unit testing is writing automated tests. So if your framework doesn't give you that option, then it is not a good unit testing framework. And the most important part of that is making a test pass or fail, or making the determination if the test passed or fail cannot have any manual steps involved. And then the last one is you need to be able to organize your tests in groups. Like you want to be able to write tests for module A and then separately from that tests for module B. And if you're working on module A, you want to be able to easily identify the tests for that module. Don't want to have to go through all tests to find the ones that are relevant for module A. So somehow those module A tests need to be organized in a group, need to be clumped together. And your framework should support you in that quest. That were the must-haves. Let's look at a few should-haves. Good performance is, I think, very important. You want to execute your tests as often as possible. You want to execute your tests with every save and potentially even more often than that. So good performance is very important. If you have to wait 5 minutes for all your tests to pass, you won't execute them as often as if running all your tests only takes a second or two. The other thing is same language. I think that is very important because switching from one language to another is a context switch, and the human brain is not really good at that. So every time you switch from one language to another, you lose time. You lose focus. You lose the ability to work as fast as you can. And the idea here is to get features out faster. Adding things that make you slower, I don't think is a good idea. So look for a unit testing framework that allows you to write the tests in the same language. For most languages that exists, but if you look in the database world, there are often frameworks that require you to know another language to write your tests in. And I don't think that is a good idea. Comprehensive set of assertions. You need to be able to test what you need to test. And comprehensive set of assertions, like an assert equal for strings, an assert equal for sets, all those things are really helpful, and you should look for them. And finally, the XUnit architecture is kind of the standard, so you should look for a framework that follows that architecture. So much for the should-haves. Now let's look at the could-haves. If you want to integrate your tests, the execution of your tests in your CI pipeline, then having a JUnit style output is really helpful. It allows the pipeline, the CI framework, to understand the test output and then fail the entire pipeline if there were failing tests. You can achieve that without JUnit style output, but having JUnit style output makes that a lot simpler. You want your framework to be extensible, particularly in the area of assertions. You want the framework to provide a way to write your own assertions. And finally, you want an integration with the IDE. You want to be able to not only write your tests in the language you're writing your code in, but you also want to be able to execute your tests while writing your code, preferably with the press of a key not a button, but at least with the press of a button. And integration with the IDE will make that possible. Having to switch to, say, the command line, that brings in the context switch again. So you're leaving your IDE, you're pulling up the command line. Even if you have that workflow down, it will slow you down because of this context switching that needs to happen. So those three groups of requirements are what I think make a really good unit testing framework. There are a few things that you might find in a unit testing framework, but that I think are irrelevant for deciding if a unit testing framework is good or not. And that is allowing you to do non-functional testing, performance testing, load testing, all kinds of tests that are not really unit tests. While the framework might give you tools to make that happen, I don't think they should influence your decision whether this is a good framework or not. In fact, I think a tool, a unit testing framework, a good unit testing framework cannot also be a good performance testing framework because the requirements are different enough that you cannot optimize for both of them. So I might even go as far as don't ignore these, but if there is a framework that has these features and another framework that doesn't have these features, and other than that they're identical, you might even want to go for the framework that doesn't have this, because it just means they optimized for unit testing, and it is probably going to be better at that task, the task you're actually looking for. And that's really all I have for you today. Thank you for showing up. If you have any questions or comments, please leave them below. If you liked what you saw and would like to see more content like this, please subscribe. Thanks for watching. Have a fabulous day.